Here are three more examples where we will determine our domain and range. Here we have a quadratic function. The vertex is at -1, -1. And when I project from my x-axis onto this curve, I see that -1 projects to the curve, 0 projects to the curve, 1, 2, 3. -2 projects, -3 projects, -4 projects. And I can see that as I go left and right, all x values are projecting onto the curve. All x values belong to the curve, because this curve is getting wider and wider and wider as it continues. So even though I have not continued to draw it, I know it's getting wider. Eventually every x value to the right will be belonging to this curve, and every x value to the left will also belong to the curve. Therefore, the domain of this function is all real numbers. The range, though, will be different, because the vertex is at y equals -1. The curve never extends beyond that in the positive direction. It does extend in the negative direction. So -1 projects onto the y-axis, -2 projects onto the y-axis, -3, -4 projects onto the y-axis. All values of y from -1 downwards are projecting onto this curve. The curve continues downwards infinitely, so all values of y to -infinity will also project from the y-axis onto the curve. But the values above y equals -1 will not be on the curve, and they will not belong to this function. So therefore, the range of this function is going to be from -infinity to -1. The vertex is included in the curve, so -1 will be included in the range. In this second example, we have another quadratic. This one opens upwards. So all values of x are projecting from the x-axis onto the curve. 2, 1, 3, 4 will also project on the curve, because as this curve goes upwards, it's also widening. So therefore, if you draw the curve upwards far enough, it will move to the right far enough so that 4 will project onto it. And the same will happen with 5 and all numbers in the positive direction towards positive infinity for the x, as well as 0, -1, -2, -3, and etc. in the direction of -infinity. All negative x values will eventually project onto this curve as the curve gets wider and wider. So again, the domain of this quadratic function is going to be all real numbers. The range is all of the y-coordinates that belong to the curve. Y equals 2 is projecting onto the curve, y equals 3 is projecting, y equals 4, and that will continue onwards as we go towards positive infinity. But all y-coordinates lower than y equals 2 will not project onto this curve. So therefore, the range of this function is going to be from +2 to positive infinity, and the +2 is going to be included because y equals +2 is the vertex, and the vertex is included in the curve. Finally, we are going to look at this step function. The step function continues onwards to the left and downwards as shown by this ... But this step function is stopping after this step. It does not go further to the right or further upwards after that point. We will do the same thing to see what the domain is of our function. Project from the x-axis onto the lines. So x equals -5 is projecting onto the line, as is x equals -4. X equals -3 does not project onto this point, which is not included, but it does project onto this point, which is included. -2, -1, 0, 1, 2, but 3 does not project onto the line because x equals 3 is not included. The points in between x equals 2 and x equals 3, those values do project onto the line. This tells me that the domain of this function is going to be from negative infinity to 3, positive 3, but the 3 is not included. Finding the range of the step function is different. We can see that y equals negative 5 projects onto this function. Y equals negative 3 projects, y equals negative 1 projects, and y equals positive 1 projects. At that point, no y larger than positive 1 is projecting onto the function. But also we have to notice that values in between y equals negative 5 and y equals negative 3, for instance, are not projecting onto the function. Y equals negative 4 does not project, y equals negative 3.5 or y equals negative 4.5 do not project. So we have to be careful because this makes it impossible for us to use interval notation to express the range of this function. The easiest way to express the range is with a set. So we use a brace. We have to put dot, dot, dot on the left side because this continues going to the left and downwards, as shown by this dot, dot, dot. And then the lowest value that we have on the graph is negative 5, so I will start by putting y equals negative 5. The next value is y equals negative 3. Then y equals negative 1 and positive 1. And then I have to stop. I close my brace. I am not putting another dot, dot, dot because the steps do not continue onwards to the right and upwards from this last step. We have enough values in our set to see the pattern. The pattern is going up and down by 2's. From negative 1 it goes down by 2 to negative 3, then to negative 5. So the next values are going to be negative 7 and negative 9, and that will continue. From negative 1 it goes up by 2 to positive 1, and then it stops because the function at that point stops. We can see therefore that finding the range of a step function is very different from finding the domain or the range of any of these other functions.